All right, let's talk about a new vocabulary word called the empirical formula. Empirical formula is the smallest whole number ratio that you can have in a compound. So empirical formulas may or may not be actual numbers of the real compound formula, but no matter what, we simplify it. So empirical formula, the key word here is simplify. Okay, so for example, you have the compound C6H12O6. We can simplify all of these numbers by dividing by 6. So 6 divided by 6, 12 divided by 6, 6 divided by 6 gets us 1, 2, 1. So the empirical formula is simplified. Remember, so this is the simplified formula. So next example, you have a 4 and a 10. So you got to think, what number can I divide both numbers by so it's fully simplified? So you're like, okay, I can divide both of these by 2. So 4 divided by 2 gives me 2. And then I have an oxygen, 10 divided by 2 gets me to 5, right? So it's P2O5. That's the empirical formula. Here you have NaCl. Remember that there are no numbers. You always imply a 1. Here, we can't simplify it anymore. So you could put a 1 here, or you could put Na, but in this situation, the molecular and the empirical formula, so molecular is called like the real formula, is the empirical formula. They are the same exact thing because we can't simplify it any further. Okay, so now this one, next one is C9H3O3 and 12. So we're like, oh, okay, all of these numbers can be divided by, and you're like 3, right? So you have a carbon, 9 divided by 3 is 3. 3 divided by 3 is 1. So you can put the 1 here or not, doesn't matter. You have 1O, and then for nitrogen, 12 divided by 3 is 4. So that would be your empirical formula. So remember, all you're doing is dividing all of these subscripts by the same number to simplify. Next is B4H8. Okay, so a common mistake here is a lot of people are like, okay, I'm going to divide by 2. So this becomes what? B4 divided by 2 is 2, and then H becomes 8 divided by 2 is 4. And you're like, wait a second, is this truly simplified? And it's not. So if you do this, you just always need to double check here, like, is this really simplified? And it's not. You can actually divide it by 2 again, right? And it becomes BH2. So if you do this, right, you want to make sure you simplify it one more time so that the empirical formula becomes BH2. Now, if you did it all in one shot, right, then, let me just erase this really quick. So if you did it all in one shot, then you know that you could divide both of these numbers by 4. 4 divided by 4 is 1. 8 divided by 4 is 2, right? So if you end up dividing by 2 and you realize it's not fully simplified, just keep simplifying until you get to the end. This one right here is C5N3O2. So you think, each number, can I simplify this? And the answer is no, right? It's already simplified. So then this would just be the same, right? Same empirical formula. Here you have a 10, 5, and 20. And you're like, I can divide all of these by 5. So nitrogen, 10 divided by 5 is 2. You have a single S. 20 divided by 5 is 4. So that would be our empirical formula. All right. So that's how you do empirical formula. Next, let's talk about molecular formula. So here, the real compound, like I said, is called the molecular formula. Too lazy to write it again. Now, like I said, the empirical and molecular formula could be the same. Do you see how right here, right? NaCl, these are the same. And then this one, C5N3O2, these were the same, empirical and molecular. So they can be the same. Now, what if you have the empirical formula, but you want to know the molecular formula? So now all we're doing is going backwards. We're starting here now, and we're trying to go back to the real formula. If we want to do that, you follow a series of 4 steps. Okay, so I'm going to do an example of going through the 4 steps. The question is, what is the molecular formula? So molecular formula is the real formula for a compound with the empirical formula. Remember, empirical formula is the simplified formula. The simplified formula is H2O, and the molecular mass is 54 grams. Okay. Step one. Step one says what? Find the mass of the empirical formula. So it tells us that the empirical formula is what? The empirical formula is H2O. So it wants us to know what the mass of H2O is, right? So how do we do that? Take two hydrogens and an oxygen and find the mass. So, right, you have hydrogen, you have two oxygens, right? So 2.016 plus 16, and then this would become 18.016 grams, right? Then what does it say? Step two says take the molecular mass. So it gave us the molecular mass. The molecular mass here, right? Molecular mass is given to you in the problem. It's always going to be given to you in the problem. This is given to you. And it says take this number and divide it by the empirical mass, right? So you know the empirical mass is 18.016. Right? So what does it tell you to do? It tells you to take 54 and divide it by 18.016. Okay, so what did we do? We took this, right? We got this number from up there, and then the 54 came from the problem. So divide it on your calculator. So when you do this, you get 54 divided by 18.016. And it's always going to be really close to a whole number. Okay, so after you divide, you should be really close. So if you're like in the middle somewhere, like you got 2.5, then you probably divided something wrong or added something wrong earlier. So here we see that 2.997 is very close to, right? It says a whole number, to 3. Okay. Then step 3 says multiply this whole number by the empirical formula subscript. So once again, we bring back the empirical formula here. So you got the whole number 3. It says to multiply by our empirical formula. So it's saying every subscript needs to be multiplied by that 3 to get our molecular formula. Remember, what did we do here? We divided to get to empirical. So now you're going backwards. So you multiply to get to molecular. We're going backwards. So here, the answer then becomes what? 3 times 2 is 6. And then 3 times 1 is 3. So this is our molecular formula. Okay, I'm going to do it one more time for you. So I'm not going to do all of these examples. I'll just go ahead and do this one really quick. So it tells us in number 4 that the empirical formula of a compound of phosphorus and oxygen is P2O5. Okay, so just to go with the same color coding system here, it tells us that the empirical formula is P2O5. Okay, it then tells us that the molar mass, molecular mass, same thing. Okay, so if we're confused here, this is the molecular mass, same thing, is 283.89. Okay, then how do we solve this problem? You have to find this mass first. So empirical mass must come first. That's step number 1. So you got to do 2 phosphoruses, right? So phosphorus is over here, 5 oxygens, and add them all together. So really quick, I can do 30.97 times 2 plus 16 times 5. So it's 141.94. 141.94. Okay. Then what does it say to do? At this point, the biggest mistake people tend to do is they divide this number up here, but it's backwards of what most people are thinking. You have to do 283.89 divided by 141.94. Say this number has to go on the bottom of the fraction, right? So here, your whole goal is to do what? Get a whole number. That's what it says. Get a whole number. So if you get a fraction, then you know you probably flip the fraction, right? So you do this on your calculator. So you did 283.89. You divide by what you got earlier, and the whole number is very close to 2, right? Then you multiply by the empirical formula, right? So P2O5 to get the molecular formula. So 2 times 2, and then 2 times 5. So what is the molecular formula? It's P4O10. Ta-da! Now you know how to go backwards and forwards between empirical and molecular formula.